The complex number u and w are defined by u equal to 2e power 1 by 4 pi I and w as 3 into e power 1 by 3 pi I. We have to find u square upon w, and we have to write it in the form of r e raised to I theta, where r greater than 0 and theta is between minus pi and pi. We have to write the exact values of r and theta. Okay, so here u, we will start with u is given 2 e power 1 divided by 4 pi I. So I have to find u square. Now this u can be written as r. This e power I theta can be written as cos. It can be written as cos pi by 4 plus I sin pi by 4. Okay. Now if I find u square, so this u square will become 4 times. Now when I square it, the angle is doubled. So this will be cos pi divided by 2 plus I sin of pi divided by 2. And therefore I can write this as 4 into e power pi divided by 2 I. So we get the value of u square. Now I have to find u square divided by w. An angle should be between minus pi by 4 and pi. So here I want a solution greater than minus pi. So this is minus pi. Greater than minus pi means I want solution in this particular region. Okay. No. This is pi by 2. Sorry. I want greater than minus pi and less than plus pi. So actually this is total 280. If clockwise I go, this is minus pi, and anti-clockwise if I go, this is plus pi. So I'm moving from here to here like this. So it is between minus pi and plus pi. Okay. Now the w is given an angle e power pi by 3. Pi by 3 is 60 degree. So that 60 degree is in this first quadrant. I have to subtract okay, so simply I will say that u square divided by w is equals to 4 e power pi divided by 2 I divided by 3 e power pi divided by 3I. So here it will become 4 divided by 3 e power. Here it will become pi by 2 minus pi by 3I. So our result is 4 divided by 3 e power. This is pi divided by 6I. Okay, this is your u square divided by w. Okay, so exact value of r is 4 by 3 and exact value of theta is pi divided by 6I. Now the next part, this is the first part, 4 by 3 e power pi by 6I. State the positive integer n such that both imaginary power of w power n and real power of w power n is greater than 0. So here your w your W is your W is 3 e power pi by 3I. 3 e power pi divided by 3I. So I have W power n. W power n will be 3 power n into e power pi n or n pi by 3I. And I have imaginary power of W power n is equals to 3 power n times sine of n pi by 3. This is imaginary power, and real part of W power n is 3 power n into cosine of n pi by 3. Now what I want this value to be 0 and this value to be greater than 0. Okay, so we know that sine 0 is 0 or sine 2 pi is 0. So if I take n 0, it will become sine 0. But here it is mentioned that positive integer. So I cannot take n as 0. Now sine pi is also 0, but sine pi, if it is 0, cos pi is become minus 1, negative 1, so it is not going to be greater than 0. So that means this n, if I take n is equals to 6, then both the conditions will satisfy. So here I will say that okay, this implies that n is equals to 6. If I take n is equals to 6, this will become sine 2 pi, which is 0, and it will become cos 2 pi, which is again 1. So 3 power n into 1 is 3 power n, positive value. So state the least positive integer n such that, so this is the least positive integer, n is equals to 6.